Good morning, this is your Math Sensei, Mr. Sensei, and we're going to be doing solving equations, but we're going to be looking at special cases when there's infinite solutions and cases when there are no solutions. So we're going to continue doing what we've been doing before using inverse operations or opposite operations, distributed property, combining like terms, moving variables, moving constants, and eliminating coefficients. So we're going to follow the exact same um, checklist that we have before. And remember, the goal is always to isolate the variable. Keep that in the back of your mind as we're working through this, that that's the goal, is to isolate the variable. So when we have variables on both sides, like we do with this first problem in the warm-up, we're going to put variables on this side and numbers on this side. Technically, that's not required, but that will help out later this week when we're working with um, inequalities. It'll help us out with that. So first step says distributed property, and sure enough, I have parentheses and I undo distributed or use multiplication to take care of distributed property. 8 times 1 gives me 8. 8 times 5 is 40. So we have a plus 40x plus 5 equals 13 plus 5x. All right, so we've taken care of the distributed property. Next, we need to see, do we have any like terms? On this side, we don't, but on this side, we can combine the 8 and the 5 will combine, and 8 plus 5 is 13. So we have 40x plus 13 equals 13 plus 5x. Okay, next, so we've combined the like terms. Next, we're looking at moving variables. Since we're going across the opposites, across the equal sign, we have to do the opposite. So I need to move variables. So I need to move the 40x is on the correct side. This 5x is not. Remember, we're doing the opposite. So the opposite of plus 5 is minus 5. And this will drop out. And we have 35x plus 13 equals 13. All right, now that we've done that, we need to move constants. And the goal here is always to move it to the side opposite of the variable because we want to isolate the variable. These two numbers represent my constants. This is a coefficient. So we need to move this constant away. So it's a plus 13. So we need to do a minus 13. And this drops off. We end up with 35x equals 0. I'm going to divide both sides. Now that we've moved that, we're going to eliminate by multiplier divide. This is 35 times x. So to get rid of that coefficient that's being multiplied, I'm going to have to divide both sides by 35. And when I do that, I end up getting x equals to 0. All right. The next problem, a little bit longer. We see we have two sets of parentheses, but we still do the same thing. We still follow the same steps. We're going to have to multiply to get rid of the distributed property, and 5 times 2 is 10, so this is 10x, and 5 times 6 is 30. So 10x plus 30 equals, then we multiply here and we get 20. 4 times 5 is 20. And going back to that triangle, a negative times a negative leaves us with a positive. And 4 times 2 is 8. So this gives me a positive 8x plus 3x. All right. So we've done the distributed property. Now we need to look at combining like terms. This side, there's nothing to combine, but on this side, I can have x's. I have 8x and 3x, so I can combine those. So these two are my like terms. And by the way, just a reminder, we have 1, 2 terms on this side and 1, 2, 3 terms on this side. Terms are always separated by a plus or a minus. So we have 10x plus 30 equals 20 plus 11x. All right. Now we need to move variables to one side. Well, the 10x is on the side that we want the variables on, but the 11x is not. So I need to move this 11x, and it's a positive 11x. So when I do this, it becomes a minus 11x. So I end up with negative 1x plus 30 equals to 20. The next thing I need to do is move constant. So I need to move this plus 30 so that it becomes a minus 30. Now I have negative 1x equals negative 10. The last thing I need to do, and by the way, even though this is a 1, I can't stop because it has to be positive. So I need to eliminate that coefficient of negative 1 by dividing by a negative 1 because this is being multiplied since it's side by sides. Well, this goes away. Now I have 1x equals 2. And once again, we have two negatives, so it's a positive. So 1x equals 10. So my answer is x equals to 10. Okay, so we're going to be looking at solving special cases. And really, this is going to be really short because then we want to do some work with some perimeter. So if the variable is eliminated and the result is a true statement, the solution has an infinite number of solutions. We write all real numbers, or we're really cool and we use what's known as the double bar R, and that's a symbol for all real numbers. So in this case, I have variables on both sides. So I'm going to put a V for the variable here, and there's my number. Well, no parentheses, so I don't have to do distributive property. But in this case, I do have like terms. I have a negative 1 and a positive 12. So this is going to be 11 plus 2z equals, well, these combine to make 12 minus 1 is 11. All right. The next thing we need to do is move variables. Well, the plus 2, so I need to move this 2z over to this side. So I'm going to subtract 2z and to subtract 2z. When I do that, I end up with 11 equals 11. Well, that's interesting. I'm missing a variable. So if there are no variables and it's a true statement, and if I sit there and go, well, if I have $11 and he has $11, that's equal. So that's a true statement. If it's true, then the answer is all real numbers. All right. Or we could say that there's an infinite solutions, or it could be really cool and make that symbol, the double bar R. All right. On the other hand, let's take a look at this. If the variable is eliminated, in other words, no variables, and the result is false, the solution has no real solutions. So let's try that out. Well, I don't have distributed property, but I do have some like terms I can combine. I can combine the negative 3 and the positive 15. And that will give me 15 minus 3 is 12. So I have 2z plus 12 equals 4 plus 2z. Now, we need to get the variables on the same side. And remember, we always want variables on the left and numbers on the right. So the next thing I want to do is move this 2z to the other side. Well, it's a plus 2z, so I'll do a minus 2z. And this drops off, and that also became 0. So I end up with 12 equals 4. Well, that's false, because 12 does not equal 4. If I have $12, that's not equal to someone having $4. So when we get a false statement with no variables, our answer is no real solutions. All right, there's no real solutions. So continuing on, we're going to take a look at doing some perimeter problems. And so it says, write the equation, solve for the variable, and find the missing side lengths. Well, the perimeter is 51. So in this case, perimeter is the distance around. So I need to add this, plus this, plus this, and it really doesn't matter what order, equals 51. So the first thing says, write the equation. Well, my equation is going to be x plus 3x plus 3x plus 2, and the perimeter is 51, and is means equals, so it equals 51. Okay, we're going to combine like terms. X plus 3x is 4x, plus another 3x is 7x. So we have 7x plus 2 equals 51. All right, I'm going to move my constant away, so I subtract 2. And I end up with 7x, because I just brought that down, equals 49. I divide both sides by 7, and it turns out x equals 7, because 49 divided by 7 is 7. So that gives me what x is. Well, that means I know how long this side is. This side right here is 7, because x equals 7. But what about this side? Well, this is 3x. This side is 3x. Instead of 3x, I'm going to say, oh, that's 3 times 7. 3 times 7 equals 21. So that means this side right here is 21. The next side is 3x plus 2. So instead of an x, I'm going to put a 7. 3 times 7 is 21, plus 2 equals 23. So that's this side right here is 23. So let's check that out. Let's grab a calculator real quickly. And 7 plus 21 plus 23 is 51. All right. So that's the way you operate these perimeter problems. Let's keep going on. So the perimeter is 623. So, okay, that means it equals 623. Oops. And my side lengths are A plus 147, and 2A. So this plus this plus this. So let's write this down. A plus 2A plus A plus 147 equals 623. Well, when I combine my like terms, I'm combining my A's, and 1A plus 2A is 3A, plus one more A is 4A. So I have 4A plus 147 equals 623. Now I need to move my constants. Well, I have 147 as a constant, and I have 623 as a constant. The goal is to get the variable by itself. So I need to move this 147 away from the variable. So this is a plus 147, so I'm going to do the opposite. And this goes away, and now I have 4A. And if I use my calculator real quickly, 623 minus 147 equals 476. All right. The very last step is to get rid of the coefficient. These are side by side, so they're being multiplied. I undo multiplication by division. This goes away and becomes 1A, and 1A equals 476 divided by 4 is 124. No, it's not. I think it's 118. 119. Wow, I'm having trouble. So A equals 119. And yes, I cheated. I used a calculator. So 476 divided by 4, 119. All right. So we know this side right here is 119. The next side is 2 times, or 2A, and that's going to be 2 times 119, and that equals 238. And then I have A plus 147, which would be 119 plus 147. And that's 266. So this side is 266. So let's add up those three sides and see what happens. 119 plus 238 plus 266. And sure enough, it equals our perimeter. So we did that one right as well. Okay. All right. So write this. We have two more questions like this. Write the equation, solve for the variable, find the missing side links. But here we have fractions, and we don't like that. But the perimeter is 144. So we know the perimeter equals 144 because is means equal. And so my equation is going to be 3/8 R plus 3/8 R plus 3/8 R plus 3/8 R equals 144. Or I have 1, 2, 3, 4. I could have written it like this: 4 times 3/8 R equals 144. And 4 times 3 is 12, because remember, I can turn this into a fraction. We multiply straight across. 4 times 3 is 12. 1 times 8 is 8. 12/8 R equals 144. And technically that reduces, but I'm not going to, just because not everyone's going to see that it reduces. But this is a coefficient and I'm multiplying. Well, the opposite of multiplying is dividing. So I'm going to multiply it. So I'm going to put an 8/12 here because it's a fraction. Dividing fractions, easy as pie, flip it and multiply. So I need to divide, so I'm going to, because it's a fraction, I'm going to flip it and multiply. Putting everything in parentheses, this becomes a 1, so we have 1R. And using the calculator, parentheses 144, close parentheses, parentheses 8 divided by 12, close those parentheses, and I get 1R equals 96. So R equals 96, but I'm not done yet. So R is 96, but I need to find out what the side length is. Well, the side length is 3/8 R. So that's going to be 3/8 times, we're plugging in that 96 for R. So parentheses 3 divided by 8, and then 96 in parentheses. It really helps put everything in parentheses, even if I didn't write it that way. And we end up getting 36. Well, so they're saying this side is 36, this side is 36, this side is 36, and this side is 36. So let's add up all those 36s. So that's the same as going 4 times 36, but 36 plus 36 plus 36 plus 36 is 144. So that one checks out as well. Okay, last problem, or last of this type of problem. The perimeter is 446 centimeters. Well, perimeter is the distance all the way around, but they didn't give me this distance or this distance. However, because I have a rectangle, this is also going to be 4W plus 8, and this is going to be 2W minus 1. Because I'm running out of room, I'm going to do this one in red, because I think things are going to get a little squinched up. So 4W plus 8 plus 4W plus 8 plus 2W minus 1 plus 2W minus 1 equals 446. Well, if I can combine the W's, because these are like terms, 4W, 4W, 2W, and 2W. 4 plus 4 is 8, plus 2 is 10, plus 2 more is 12. So now I have 12W. 8 and 8, 16. Take away 1 is 15. Take away 1 more is 14. So 12W minus 14 equals 446. I need to move my constant. This is a minus, so I'll make it a plus because I have to do the opposite. Because remember, we want to isolate that variable. We want that W by itself. So now we have 12W equals 432. And this is being multiplied, so I'm going to divide because we're going to do the opposite. All right, and if we take 432 and divide it by 12, we get 36. So W is 36. So we have two sides to work with, 2w minus 1. So 2 parentheses 36 minus 1. Oops. So 2 times 36 is 72 minus 1 equals 71. So this side right here is 71, and this side right here is 71. And then we have 4w plus 8. So 4 times 36 plus 8. So let's use our calculator. 4 parentheses 36 plus 8 is 152. So these two sides are 152 and these two sides are 71. So 152 plus 152 plus 71 plus 71. And we ended up getting 446, and that's what we started with. All right. Next one. Just solving with fractions. This is just reminding us how to do it. We need to get the variable by itself, so we have to move our constant. We have two constants, 7 and 17. To move the 7, I have to add 7 to both sides because it was a minus. And remember, the goal is to get that variable by itself. This becomes 0. This is negative 3/4 x equals 17 plus 7 is 24. I'm multiplying here, so I have to undo multiplication. I do that by division, but it's a fraction. So dividing fractions, easy as pie, flip the second and multiply. So I need to flip it and multiply. Well, when I do this, this just becomes a 1x. But I also have to do it to the other side. Well, I'm going to put this over 1, and I can plug this into the calculator, parentheses 24, parentheses negative 4 divided by 3. Once again, be real careful that you're using this button for the negative button, right? And let me close those parentheses, and we end up getting negative 32. So our answer to this problem is x equals negative 32. On this particular problem, once again, we have two constants, the 10 and the 4, but the goal is to get the x by itself, so I need to move the 10. So I need to do a minus 10 to both sides. Now I have negative 2/3 x equals negative 6. The signs are different, so we subtract the number and keep the sign of the larger. 10 minus 4 is 6. 10 is bigger than 4, so we'll keep the 10 sign. All right, we're multiplying by negative 2/3. So I need to undo multiplying, and that's by division, but it's with a fraction. Dividing fractions, easy as pie, just flip it and multiply. So this is going to be 3 over negative 2. And this will also be 3 over negative 2. This will go away and become 1x. I'm going to go ahead and put this negative 6 in parentheses, and we'll plug that into the calculator as well. Parentheses negative 6, parentheses 3 divided by negative 2, and we end up getting 9. So 1x equals 9. Our answer to this is 9. And we have a negative and a negative, so this is a negative 2. And remember, by the triangle, a negative and a negative gives us a positive, and that's what we got on the calculator. All right, I appreciate it. I'm going to make that positive look a little better. I appreciate you watching. Look forward to seeing you on the next one.